This video is going to focus on the number of roots you can have, how many are real and how many are imaginary. So to get started, let's go back and just review basic complex numbers. I is the square root of -1, which means I squared is -1. I to the fourth is +1. And we don't really need to worry about this one. So we don't have to worry about that one too much. This is all we really need to be concerned with. Complex numbers look like this: a plus bi. A is considered the real portion, and bi is the imaginary portion. Just a generic way to represent a complex number. A little bit of review on simplifying complex numbers or simplifying with imaginary roots. This is -1 times 25. -1's a perfect square. 25 is also a perfect square. So this simplifies as 5i. Radical 50, -50 rather. I've got -1. I've got 25. I have 2. This simplifies as 5i times the square root of 2. And then -8. -1 times 4 times 2. This simplifies as 2i radical 2. And the cube root of -8 is not imaginary, but just threw that in there. That odd index makes that a real number. All right, imaginary roots versus real number roots. Real number roots do cross the x-axis. They cross the x-axis, so they're x-intercepts. Imaginary roots do not cross the x-axis. Real number roots are either rational or they're irrational. Remember, the irrational root, the non-perfect square, occur in the positive-negative pairs. Imaginary roots are I. They also occur in pairs. So these also occur in pairs. And you can find both by factoring. So we can find both of these by factoring. And when your remainder is 0 after a division problem, you know you found a root, whether it's real or whether it is imaginary. So the next skill in this unit, I'm going to bypass all of this. I'm going to move to this spot right here. The number of real number roots plus the number of imaginary roots is always equal to the degree of the equation. It's always equals n, the degree of the equation. This is really simple little skill, but it is part of this standard. If I have a degree 5, I will have 5 roots in some combination of real and imaginary. So I'm going to draw a little column, make little columns right here. My total column here should always equal n, standing for the degree of the equation. Remember, imaginaries occur in pairs. So here we go. So real number, I could have 5 real number roots, no imaginary roots, giving me a total of 5 roots. I could have 3 real number roots and 2 imaginary roots, giving me the total of 5 roots altogether. Or I can have 1 real root and 4 imaginary roots, giving me that total of 5 roots altogether. So the ability to make this little chart and separate real and imaginary into 2 columns is a standard skill for 2B. Moving to the next page. Here I have a degree 8. This is a degree 8. And that means I need 8 roots in a combination of real and imaginary. So go ahead, make your columns. I could have 8 real number roots, no imaginary roots, giving me a total of 8 roots. I could have 6 real, 2 imaginary, giving me a total of 8. I could have 4 of each, giving me a total of 8. I could have 2 real, 6 imaginary, giving me 8. Or I could have no real, 8 imaginary, giving me a total of 8. So remember, the imaginaries occur in pairs. So I can only have an even number of imaginary every time. Now this little, the exercises here, they're just asking you to state the number, meaning how many can I have? Whoops, hold on, how many? Let me get a better highlighter color. How many roots can I have? And possible, how many are real and how many are imaginary? And the number of positive and negative. I am going to skip that skill for right now. How many are positive? How many are negative? Let's just make a little chart here to determine how many of each type we will have. This could look like something like this. You can draw it as rows or you can draw it in columns. I could have real, I could have imaginary. I have a degree 5 right here. So I've got a degree 5, which means I could have 5 real. I could have 5 real and no imaginary. I could have 3 real and 2 imaginary, 1 real and 4 imaginary. Notice that the sum of each column, I would have 5 in each column. Let's do, here, this is an even number. Let's do 4. So let's say you're asked to list how many complex roots, real versus imaginary. So I would have real, imaginary. You can either do a row or a column. It doesn't matter. So here I could have 4 real, no imaginary. I could have 2 of each, or no real and 4 imaginary. Notice that the sum in each column, I will have 4 roots each time, just telling which type, real versus imaginary, which combination am I looking for. And let's do this one. Let's do the 5. So I've got real, I've got imaginary. I could have 5 real, no imaginary. I could have 3 real, 2 imaginary, 1 real, 4 imaginary, keeping in mind that that imaginary row or column, always even numbers, they're always occurring in pairs. This is just more information for you to have when you get to the end and pull everything together. And I think that's really all I want to do in this video. This little section right here, pulling it all together, I'll highlight where this skill comes into play. State the number of complex zeros, the possible number of real and imaginary. So that's what we just went through. And it's always interesting at the end when you get your zeros to come back up and check. So here we did this one in class. Here, this would be looking at, this is a degree 3. So real versus imaginary, real and imaginary. And since we already know the results, we can see down here that we had 3 real number roots. So my combinations could possibly be, I could have 3 real, no imaginary, or 1 real and 2 imaginary. So in this particular case, I had 3 imaginary roots.